All right, this video is going to go over 12.1b, which is more rational exponents, but now we're going to be doing operations like multiply, divide, that kind of thing. So in order to do this, you have to be decent at adding and subtracting fractions. So if I asked you what 2/3 plus 1/5 was, if you can't answer that, you can't do this. So the key to doing fractions is getting a common denominator. The common denominator here would be 15. I have to get the denominator of both these fractions to say 15. So how do I do that? Well, this first fraction I multiply by 5. When I say I multiply by 5, I'm really scaling it by 5. I'm multiplying by 1. 5 over 5 is 1. So I'm not actually changing any values. I'm just changing the way it looks. But 10 over 15 is still 2/3. I didn't change the value of that. And the second fraction, to get it to 15, I would have to scale it by 3. So it'd be 3/15. So the answer to this is 13 over 15. Again, if you cannot do common denominator, you're basically wasting your time by watching this video. So, all right, let's go ahead and get started. This first one, you're multiplying these b's. Well, you only multiply the exponents when it's like power to a power like this one. If it's not power to a power, then you're adding or subtracting these exponents. You're just combining them. So really it's like b to the 2 plus negative 3/4. So you have to know what 2 minus 3/4 is. So that would be make 2 8/4. So really it's like 8/4 minus 3/4, which is 5/4. So the answer here is b to the 5/4. Now, if they want it as a root, this root would be the 4th root of b to the 5, which you could even simplify that further by taking a b out and having 1 left over, like that. I hope that made sense. Combine those numbers, get to 5/4, write it as a root. All right, this next one, this is power to a power. So you're multiplying. So it's really like x to the 1/6 times 3/4. Now, when you multiply exponents, me personally, I like to reduce as I go rather than multiply it out. Yeah, you could multiply this out and call it 3 over 24 and then reduce. That's fine. But I just like to reduce as I go. And so here's what I mean. 3 and 6 reduce. They're both divisible by 3. So divide them both by 3. And so now you just multiply straight across. The top makes 1, the bottom makes 8. So it's 1/8. All right, so this one is just x to the 1/8. And then to write it as a root, that would be the 8th root of x to the 1. Okay, the next one. Well, now we're back to adding these exponents, but you need to pay attention on this one. The 3 has a 1 and the 2 has a 1. So they're not going to be kind of added or subtracted there. They're going to be multiplied. 3 times 2 makes 6. It's only on the a where you're going to do 3/4 plus 3/2. So you have to change 3/4 plus 3/2. You have to change 3/2 to get your common denominator. So I'd be like, okay, 3/4 plus, scale it by 2, 6/4, which makes 9/4. So really it's like 6a to the 9/4. If you wanted to write that as a root, your 6 has a power of 1, so it's not included in the root. So it'd be like 6 4th root of a to the 9. And then you could simplify that even further by taking 2 groups of a's out. So it's 6a squared 4th root of a to the 1, just like that. All right, now when we get to the dividing ones, like number 4, instead of adding these exponents, you're subtracting them. So it's really like x to the 6/5 minus 1/2. So you have 6/5 minus 1/2. Your common denominator there is going to be 10. So you get 7/10. So you get x to the 7/10. Well, to write that as a root, that would be the 10th root of x to the 7. Okay, the next one. You have a power to a power, so you're going to be multiplying these powers. We'll give the 4 its 1 and then distribute the 3. So it's like 4 to the 1 times 3, which is 3, x to the 1/2 times 3, which is 3/2. And so 4 cubed is 64. And then this x to the 3/2, that's like a square root of x cubed. And you can take an x out there. So my answer would be 64x1 with another x under a square root, just like that. Okay, this next one, you're adding these exponents. And so you're going m to the negative 3/4 plus 1/2. Well, negative 3/4 plus scale 1/2 by 2 to make it over 4. So it's really 2/4. So you get negative 1/4. All right, so you got m to the negative 1/4. Well, that's the 4th root of m to the negative 1. And remember, you're not supposed to have these negative exponents. So the way you fix this is you have the 4th root of, call it m over 1, and the negative exponent means it goes to the bottom of the fraction. So 1 over m to the positive 1 now there. So the 4th root of 1 over m really would be my answer. All right, now these are getting more complicated very quickly. So number 7. This 27 has a power of 1. This is a power to a power, so you're going to distribute. So it's going to be 27 to the 2/3, x to the 3/4, okay, sorry about that, x to the 3/4 times 2/3, y to the 9 times 2/3. All right, so I'm going to go ahead and do like 3/4 times 2/3. We'll leave this x, 27 to the 2/3. Okay, x to the 3/4 times 2/3 is 1/2. Y to the 9 times 2/3 is 6. So really it's like the cube root of 27 squared, the square times the square root of x to the 1 times y to the 6, just like that. All right, now you would have to handle this cube root of 27 squared. The cube root of 27 is 3. Then you square it. So this all turns into 9. So my answer here is 9. I had y6, and then I had a square root of x, just like that. You could put the 2 for the square root if you wanted to. All right, moving right along. The 16 has a power of 1, so this is a power to a power, so I'm multiplying this. So it's like 16 to the negative 3/4, okay? So that's the 4th root of 16 to the negative 3. Well, the 4th root of 16 is 2. So it's really like 2 to the negative 3, which is like 2 cubed, which is 8, but then you have to send it to the bottom. I guess I should show it like this. It's over 1, send it to the bottom, so it's 1 over 2 cubed, which is 1/8. I think that made more sense. Okay, this next one, power to a power, so you are multiplying and distributing this 1/2 to everything. So it's like 25 to the 1/2. X to the negative 6 times 1/2 is negative 3. Y to the 4 times 1/2 is 2. All right, so you have the root of 25, and then you have x negative 3, y 2. Well, the root of 25 is 5. And this is close to your answer, but notice this x negative 3. He's going to have to go to the bottom of a fraction and become x positive 3. So my answer here would be 5y squared on top, x positive 3 on bottom. Okay, next one. Negative 128 to the 3/7. So that's really like the 7th root of negative 128 cubed. Okay. All right. So you would have the seventh root of, you would have the seventh root of negative 128 is negative 2. So I guess the way you could kind of look at it would be if you broke down 128, it's 2 to the 7. So you could kind of look at this problem as if it was the seventh root of 2 to the 7 cubed. This 3, it doesn't really matter if it's inside or outside of that root. It's going to get cubed regardless. So this is kind of, and I would actually make it negative 2 like that. This is kind of how I'd look at it. And I'd realize that a seventh root cancels a seventh exponent and just drops the negative 2. That's kind of how I'm doing it. So I hope that made sense. Or you could just know that 2 to the 7 is 128. That's how I did it, but to each his own. Anyways, negative 2 cubed is negative 8. All right, this next one, 400 to 3 halves. Well, that's the square root of 400 cubed. So do the square root of 400 first. That's 20. So it's really like 20 cubed, which is going to be 8,000. So that's how I would do that first page. All right, now on the second page, it seems to be kind of a review of the last lesson, but let's just go ahead and knock it out. Remember the root number, that 3 is your denominator. So this is like m to the something over 3. Well, the exponent there is a 1, so it's m to the 1/3. The next one would just be n to the 4/5. The next one would be 3x to the 1/4. Now, if you write your answer like this, technically it's wrong. You either have to group it, that whole 3x is under the root, right? So they're grouped together, or you can do it individually. Same thing as 3 to the 1/4, x to the 1/4. But if you don't put parentheses or something, it's wrong. All right, the next one, you had 5 to the 1 and then the square root of n cubed. So the 5 has a 1, and then the n, the exponent's 3, so the numerator's 3, and it's under a square root, so the denominator's a 2, just like that. All right, the next one, the cube root of negative 125 xy2. So this right here is negative 5 cubed. So when you do the cube root of that, it's going to cancel and just drop negative 5 to the 1. Now the x and the y2, well, that's still going to have a rational exponent. It's going to be x to the 1/3, y to the 2/3, like that. Okay, the cube root of 16y7. Go ahead and change 16 to be 2 to the 4, okay? And so what's going to happen is you're going to have 2 to the 4/3, y to the 7/3, like that. Okay, now they want me to write these in radical form. So they want it with roots. So this one, I don't want to write that big. This one would be the cube root of 8 to the 1, x to the 2. And then you could even go further here. The cube root of 8 is 2. So it's like a 2 to the 1 out front with the cube root of x squared still in the root. The next one's super easy. It's just a 5th root because that's the denominator, x squared. The next one's easy as well, 4th root of a to the 9. Oh, and by the way, maybe they want us to kind of, like on this one, we could take out some a's. So we could take out 2 groups of a's and have 1 left over in that root. So I guess that's what they were going for there. All right, the next one, it is a 5th root of x to the negative 1. Well, you can't have that negative exponent, right? So this means it has to swing to the bottom. So it becomes the 5th root of 1 over x to the 1, like that. All right, this next one, they're both a 5th root because that's the denominator for both of them. So they're both in a 5th root. a to the 4, b to the 8. And then the only other thing here is you can take out some b's. So you can take out a group of b's, and you'll have the 5th root of a to the 4, b to the 3. All right, the next one, give the 3 its 1. So it is not going in the root. And the root only applies to the x. It is a cube root with x to the 1 inside. All right, this next one, they're both square roots. So it's like the square root of 4x cubed. Well, the square root of 4 is 2. And you could even, if you wanted to, you could change it like to 2 squared if that makes more sense to you. Like this, and then you could be like, oh, I can take out a 2 and an x, and then left over is just one of those x's. So you could approach it that way. I would just look at it and be like, okay, the square root of 4 is 2, and then I can take out an x. Again, it doesn't matter. All right, so this next one, it's a power to a power. So I'm going to be distributing this 5 halves. So I'm going to get like 9 to the 5 halves, x to the 20 over 2, which is 10. 4 times 5 halves is 10. Y to the 6 times 5 halves is 15. All right. So now really it's only the 9 that's going to go under a root. And it's going to be like, so the x10 and the y15, they're good. They're hanging out outside this root. Under the root, which is the square root, by the way, you have 9 to the power of 5. Well, do the square root of 9 first. The square root of 9 is 3, so it's really like 3 to the 5, x to the 10, y to the 15. Again, I just did the square root of 9 to get this 3. The exponent of the 5 doesn't go away. And I would not leave it like this. 3 to the power of 5, I think it's 243. So I would do 243 x10, y15. And then this last one, okay, this one's kind of tricky. You've got everything is going to get the power to the power. Everything. So it's really like 16 to the 3 halves, x to the 15 halves. I'm multiplying 5 times 3 halves. Y to the 6 times 3 halves is 9. And on bottom, they get the exponent, the power to the power as well. So it's like 25 to the 3 halves, x to the 3 halves, y to the 4 times 3 halves is 6. All right. Now there's a couple things I'd probably do here. I would go get these values because it's really like the square root of 16 cubed. Well, the square root of 16 is 4, so it's really like 4 cubed, which is 64. And then same thing with the 25 to the 3 halves. It's like the square root of 25 to the 3. Well, the square root of 25 is 5, so it's really like 5 cubed, which is 125. So I'm going to make those changes now. And to keep it kind of simple, that's the only thing I'll change right now. So this doesn't change, this doesn't change, this doesn't change, this doesn't change. The only thing I changed was 16 to the 3 halves became 64. 25 to the 3 halves became 125. All right, so I'm pretty close to having my answer. Now, this part, I'm going to be subtracting these fractions. So you're going to get 6 there, x to the 6. So I'm ready to start what I'm going to call my final answer. It's going to have that 64 and 125. Those do not reduce. With the x's, we're subtracting those fractions. We get x positive 6, so it goes on top. And then with the y's, you're subtracting this as well. 9 minus 6 is positive 3, so it goes on top as well. So this would be my answer. All right, some of those do get kind of tricky, but as long as you remember the rules and what you're allowed to do, you should be okay. So yeah, hope this video helped.